Alright, so we have related rates here. This kind of describes it. I'm going to do it both at the same time, talking about this as I do the example. So we have an 11-foot ladder. That's the red line on there. It says it starts flush, leaning flush against the wall, and then the base of the ladder starts to slide away somehow, or is pulled across here, and the ladder starts to fall down. So make a sketch if possible. Name the variables and constants. So the ladder is 13 feet. So put that on there. And the ladder is sliding away from the wall at 3 feet per second. So we could say, so that's a rate. So these are called related rates because there's more than one rate in the equation with respect to t. So I'm going to call this x. And so the rate at which that's moving away is going to be dx dt. And that's 3 feet per second. So that's a derivative. That's a rate of change, a slope. Okay? So find the rate at which the top of the ladder is moving down the wall. So if we let this be y, they're asking us about dy dt. I didn't leave myself a lot of room over here. So dy dt equals question mark. So that's what we're trying to find. How fast is this moving compared to how fast that is moving? Okay, so that was 3 feet per second. Find the rate. So when we say that, we want to identify what that is in our writing stuff down. So those are all of our first two steps. Okay? Now, what else do they tell us? They tell us that t equals 1 second. So we need to, at 1 second, so this is a little bit tricky. So if you think about it, this told us that x, the distance, is 3 times t because it's moving at 3 feet per second. So every second, that distance will be multiplied by 3. Now, they told us we're doing this problem at 1 second. So that means that x will be 3 times 1, or 3 feet. So that's something that we know there. Okay. Now, the next step is to write an equation that puts all this together. Well, I hope when we all look at that, we can see that's a triangle, and we have the sides of a triangle. So if we have the sides of a triangle, then we could be using perimeter, but it doesn't really say anything about that. So there's a relationship between these three sides, the Pythagorean theorem. So our equation, step 3, is going to be x squared plus y squared equals, and 13 is a constant. That's the length of the ladder. That doesn't change. This changes and this changes, but the length of the ladder stays the same. Okay? Now, the next step is to differentiate with respect to time, and use the chain rule if you need to. So here, that's going to be 2x. Now, the difference is everything here is with respect to time. Everything here is with respect to time. So we learned in our last lesson, 2.5, implicit differentiation. So if we're taking, up until today, we always took the derivative with respect to x, dx, dx, dy, dx. Now in this lesson, we're taking the derivative with respect to time. So it's going to be dx dt. So we are going to get a derivative right there, whereas before we always had dx dx right there, and that was 1. So now we have to be particularly careful about that. And so here, hopefully you can see, pause the video and think about it. That should be dy dt. This messes up people sometimes. That's a constant. 13 squared is a constant, and the derivative of a constant is 0. All right, so now what? Now we can start plugging in some numbers. So actually, before we do that, we could multiply this whole thing by a half to cancel out those 2's. So now we would just be left with x dx. So x is 3 feet from there, and dx dt we found was 3 feet per second. Okay, plus y. Well, if you think about it, if x was equal to 3 at the moment that this, remember, calculus is about the instantaneous rate of change. It's about at an instantaneous moment. So when x equals 3, we can find y. We still have too many variables right now. We have y and dy dt. We're trying to solve for dy dt, so there must be a way to solve for y. So, and there is, we can use the Pythagorean theorem right here. So that's going to be, what, 3 squared plus y squared equals 13 squared. So that's going to be y squared equals 169 minus 9 is 160. Take the square root of both sides. The absolute value of y is going to be, that's going to be root 16 times root 10. So that's going to be 4 root 10. So technically we get plus or minus 4 root 10, but we don't really need the negative value there. So coming back up here, we're going to plug that in for y right there. So that's going to be 4 root 10 times dy dt equals 0. So I'm going to do 2 steps at once. I'm going to subtract 9 over here, and then I'm going to divide by 4 root 10. And now, here's where it gets a little bit tricky. So this is a rate. Normally on a rate question, I'll say indicate units of measure if they want that, but this was feet per second. So that's going to be feet per second. Now the tricky part here is this said at what rate is it moving down? So that already accounts for the negative. So if we said that it was down at a negative, that's a double negative. I ain't got no paper. If you ain't got no paper, that means you have paper. That's one of my quotes from one of my students a long time ago. So it's really annoying, but the answer to this question is going to be 9 over 4 root 10 feet per second. That's the rate at which it's moving down. Now, if the question just said, what rate is the top of the ladder moving, and that wasn't there, then we would have to use the negative in our answer. At what rate is the top of the ladder moving on the wall? Then we would have to have that. But that's tricky. You have to be careful when you're looking at that. Okay. So now we have a follow-up question about that same situation. So it says, at what rate is the area? Find the rate of the area. Well, what's area measured in? Area, or what's the formula for area? Is capital A. So the rate of the area is going to be dA dt. So that's what the question is asking you for. Okay? So the picture, most of that other information is still the same. Now, so that's step 1 and 2. And this is part of step 2 here. What are we trying to find? So then step 3 is an equation. Well, the area of a triangle. Well, that's pretty basic. There are multiple formulas for the area of a triangle, but 1/2 base times height, but the base is x and the height is y, so 1/2 x times y. Step 3. Step 4 is to take the derivative of that. So dA dt equals. Now that's the product rule, and I'm going to factor the 1/2 out of the way. So I'm just going to use the product rule on x and y. All right. So let's move that over here a little bit. So the derivative of the first thing is going to be dx dt times y plus x times dy dt. All right, and we should have all that stuff up there in different places. So dx dt was 3, y was 4 root 10, x was 3, and dx dt was 3. Dy dt was, now here, this is where that negative comes. This should be negative. Okay? The reason that y is negative is because this length is getting shorter. You can't see that. The reason that dy dt is negative is because this is getting smaller, this distance. And dx dt is positive because this is getting larger. Okay? So, pretty tricky here. You got to keep the negative in here. So that's going to be 4 root 10. We do not have to rationalize the denominator anymore. Okay? Now, this is going to be, let's see, that's 12. So, I guess I could leave that out there. 12 root 10. Let's see what happens. So that's 12 root 10. And over here, this is negative 27 over 4 root 10. So if we get a common denominator here and multiply this by 4 root 10 over 4 root 10, that would be 48 times 10, which would be 480. So that would be 480 minus 27 over 4 root 10, getting a common denominator. And then finally, probably just distribute that in there and subtract that. So that's going to be 453 over 8 root 10. Now think about it. You're asking the change of the area. So the change of the area is going to be measured in feet squared per second. All right? Okay. Angle of depression and angle of elevation. So this question is about the angle of elevation, but we may be asked about angle of depression, and that students get that wrong a lot. So I just want to go over that really quickly. So if we had a person standing on the side of a cliff, and down here there was water, and there's a boat out there, water, okay, and they would say that that person is looking down at a boat at a 30-degree angle of depression. So the problem, the mistake that a lot of people make is they go and they say, okay, this person is looking down at that boat, whatever, like this, and then they use that triangle because they're like, oh, there's a triangle, and then they put the angle right here. The angle of elevation or the angle of depression comes from your line of sight looking straight out. So what you need to do is you need to draw their line of vision, which would be up here. And one way I tell students to remember that is to draw the triangle in the sky. If you have an angle of depression, if you're depressed, look up to the sky. Look up to the beautiful sunset or something like that. Okay? Draw your triangle in the sky because your angle of depression is up here, not in here. That'll give you the wrong answer. Okay? So there we have that. Now that doesn't have anything to do with our problem, but it's related to the angle of elevation. Okay, so a nice little balloon there for you. Steps 1 and 2 are to draw a picture and write down all the information that we can. So a balloon rises at 15 feet per second from a point on the ground. So we need the ground here, and from a point on the ground, it rises from a point on the ground, so that's right here. And that point is 45 feet away from somebody who's looking up at that balloon. Okay? So we know that this is 45 feet. The balloon rises at 15 feet per second, so I can call this y. And dy dt is going to be 15 feet per second. Okay? Find the rate of change of the angle of elevation. So find the rate of change of the angle. So that's this angle right here. So that's going to be theta. And what we're trying to find is d theta dt, the rate of change of the angle. D is not very good there, but when the balloon is 60 feet above the ground. So that's something I should have mentioned this in the last one too probably, but I call that a post-derivative substitution. The mistake that some people make is they try to plug that number in too early, and if you plug it in too early, it changes your derivative and messes things up. So you have to kind of be conscious of putting in some information after you take the derivative. Like in the last ladder question, we found x and y, and we plugged them in after we took the derivative. We had x, we found y using the Pythagorean theorem, it was 4 root 10, and we plugged those in after we took the derivative. Alright, so I think I have all the information down that they gave us. So now step 3 was to come up with an equation. Alright, so here the difference is we don't have the hypotenuse, we just have these two sides, and we have this angle. So hopefully that kind of, you think of trigonometry, angles and sides is trigonometry. So the equation is, this is opposite and adjacent. So the trig, think about it, write it down, which trig function? So that's tangent. Tangent of theta is opposite over adjacent. So that would be y over 45, but I'm going to rewrite that as 1 over 45 times y. Same thing, y over 45. But in taking a derivative, I just want to look at it that way a little bit. Okay? So, now what? Step 4 is to take the derivative of the equation that we just found. So step 4, the derivative of tangent, now hopefully you have your trig derivatives memorized. Those are going to be on our next test or quiz, or the one we just had actually, probably. The derivative of tangent is secant squared. So we're going to have secant squared theta, but we took the derivative with respect to theta, so that's where our d theta dt is going to come in, which was what we're trying to find. And then we're going to have 1 over 45. And the derivative, that's a constant. It'd be like if it was 2y, the derivative of 2y is just 2. The derivative of this is going to be 1 over 45. And then that's going to be dy dt. Alright? So, there must be some things that we can plug in here. So, the angle, it says we don't have to find the angle. So, if we don't have to find the angle, then that means the question is, what's the secant of theta? So if we draw this triangle over here, so it would be something like this. Now, if this is theta, this is 45, and this is 60. Well, let's think about that for a second. Those numbers look kind of related to each other. They're both multiples of 15. So this is actually 3 times 15, and this is 4 times 15. So hopefully some of us remember, maybe from geometry, that was a long time ago, but maybe from another class, Pythagorean triples. And 3, 4, 5, the 3, 4, 5 triangle is very prominent in mathematics because we know it works, and so we use it a lot. So 3 times 15, 4 times 15, 5 times 15. Alright, so secant is what we're trying to find over here. It's secant. So secant is 1 over cosine. So if you think about the cosine of this angle, cosine is is adjacent over hypotenuse. So that would be 45 over, if you want that, that's 75. But I would, so secant is the reciprocal of cosine. So instead of adjacent over hypotenuse, it's hypotenuse over adjacent. So we would have this over this. So we would have 5 times 15 over 3 times 15. Okay. So that's going to cancel out. So that's going to be 5/3. This cosine itself would have been 3/5. But the reciprocal is 5/3. So now we can plug that in here. So we're going to have 5/3 squared. Okay. And we have d theta dt is what we're trying to find. And we have 1 over 45. And they told us that dy dt was 15. And that's going up, so that's going to be positive 15 All right. So if we want to solve for this, we're going to multiply both sides by, to get rid of this, I'm going to multiply by 9 over 25, multiply by the reciprocal. 15, this reduces to 1/3. And then this reduces to 3. So d theta dt equals 3 over 25. In calculus, we don't really use degrees very much. It would be radians per second. All right. Okay. So these are pretty common questions. There's a good chance you'll see each of these or a slight variation of these again. Okay. So draw a picture. Steps 1 and 2. Draw a picture and label some things. So this little side note over here, they're asking you about a sphere. So the volume of a sphere, I think we already talked about that earlier in chapter 2. But hopefully some of you remember that. That's 4/3 pi r cubed. And the surface area, we talked about how it's kind of interesting that if you take the derivative of that, you get the surface area. So that would be 4 pi r squared. So maybe that'll help you remember that in the future. So water runs into a conical tank at 9 feet. Okay, so 9 cubic feet per minute. So we can start writing stuff down. So the rate of change of the volume, that's going to be dV dt. It's 9 cubic feet per minute. The tank stands point down, so at that point we can start drawing a picture. And got that down there. And cone pointing down. The height of the cone is 10 feet. So here to here, that's 10 feet. This comment was just to help you on your assignment. It doesn't have anything to do with this problem. They're just both volume problems. That's the only thing. The way they're related. Okay. And the radius is 5 feet. Okay, how fast is the water level rising? So I'm going to call that the height. So that's H. That's going to be R. How fast is the water level rising? So that tells us that we're trying to find dH dt when the water is 6 feet deep. So that's going to be one of those post-derivative substitutions. That's what we're going to plug in after we take the derivative. So that's why I have it in light blue there. All right, so I think I've written down just about everything that I can write down. I don't really see any other information. So now we're going to go to our equation. So we're talking about volume, the volume of a cone. So that's going to be the volume of a cone formula. So that's going to be 1/3 base area times height. Okay? So let's think about this for a moment now. There was no reference to the radius changing. So there's no reference to dr dt. So that means that we don't want r in our equation. Now, we could make an equation with r to find dr dt, but that's going to be harder. So because we don't have a dr dt, so we don't want r. Because there's no dr dt, we don't want r, so we have to get rid of r. So if we look at this, back to our geometry days, as this water rises in here, we're going to get similar triangles. We're going to have the overall cone, and we're going to have the cone made by the water. So the big triangle is going to be 5 and 10, But we're also going to have our smaller triangle, which is going to be R and H. Okay? So, since we're trying to get rid of R, I'm going to put R over H equals 5 over 10. So R, multiply both sides by H and reduce this fraction. So some of you lost points on the quiz. You had a quiz today. I'm making the notes now. Because you didn't reduce a fraction. Make sure on our test you reduce your fractions. You don't put 5 over 10 as an answer. Now, on the real AP test, leave it 5 over 10. But we need to practice for multiple choice questions also. So we're going to reduce everything during the year as we practice. So this is going to allow us to get rid of R. So now we're over here and we have volume equals 1/3 and we have pi, and R is H over 2 or half H, however you want to look at it, and then times H. So if you square that, you're going to get H squared over 4. So that's going to be pi over 12 times H cubed. So this is kind of like a system of equations. It's not kind of like, it is a system of equations. We had 2 equations, and we substitute out that variable. Okay, memorize how to do this question. This will be tested at some point. Now, that's step 3. All that was step 3. Step 4 is to take the derivative. So the derivative of the volume with respect to time equals, bring this down, that's going to be pi over 4, reducing because you'll have 3 over 12, and H squared, and dH dt, which is what we're trying to find, dH dt. So dr dt is 9, so we have that, we have pi over 4. H, that's where the H comes in. It's said to, I guess I could switch this to the light blue now. It said when the water is 6 feet deep, so the height of the water is 6. And then we have dH dt that we're solving for there. So if we square this, we get 36, and 36 over 4 is 9. So we're going to have 9 equals, this is going to be 9 pi dH dt. So we're going to divide both sides by 9 pi, and that's going to reduce. So dH dt is 1 over pi. And then think about the units. So what is the height of this cone measured in? It's going to be measured in feet. So the rate of change of the depth of the water is going to be feet per second. Okay? And so that's going to be our answer. And then the question here tells us, think about the units of your answer. And you can get the units from the original problem. So this explains that. All right? And I'm probably going to run out of time here, but maybe I'll give it a shot. All right, a particle is moving along this curve, so draw a picture, label stuff. So, all right, got that, we've got that, we got the 0.42, so 1, 2, 1, 2, 3, 4. So we might want to do a graph of that. It's going to be 0, 1, 1, 4, 2. So it's going to look like this. As the particle passes through the 0.42, its x-coordinate increases at a rate. Okay, so the x-coordinate increases at a rate. So that's going to, I'm going to call that dx dt. The rate of x is 6 centimeters per second. Now that's increasing, so that's going to be positive. Now it says, how fast is the distance of the particle? How fast, that's a rate. So that's going to be, now the distance from here, so what they're talking about, if I pick some random point on here, call that point xy, so that is xy. This will be the distance from the origin. So we're looking at dd dt. That's what we're trying to find. How fast is this distance changing when x is changing by 6 centimeters per second. Okay? So we need an equation. So we need an equation that has the distance in it because we need to get dt. So the distance formula is the square root. We're talking about the distance from the origin here. Okay, so that's going to be x minus 0 squared plus y minus 0 squared. Now, at this point, what color did I use on that? I did it in red. So what you should see here is, just like in the last problem, we're missing something. We don't have dy dt. So we don't want y. But we have a nice solution to that problem. Y is x to the 1/2. So we can get rid of y. So this is going to be x to the 1/2. So if we simplify that a little bit, let's rewrite that as 1/2 power. So that's going to be x squared. And this is going to be x to the 1/2 squared, which is just x. So that's our equation. So in the last two examples, we had to eliminate a variable. Now, that's step 3. Step 1 and 2 is to list everything that we can list and draw a picture. Step 3 is to come up with an equation, see if we have to eliminate that extra variable. And step 4 is to take the derivative. So now we're going to take the derivative. It's going to be 1/2. And hopefully, some of you are looking at that. And again, I haven't been saying it much today, but pause the video. Pause the video and do as much as you can do. You should all be able to take the derivative of that. So you could pause this right now and do that. And I'd like to stop talking because I'm thinking you're paused, so you're not listening to me, but you unpaused and now you are. So that's going to be negative 1/2, and then this is the chain rule, derivative of the inside. So that's going to be 2x plus 1, and we need to have a dx dt right there because we took a derivative with respect to x. Alright, so now x is, what do we want to do here? If we plug in 4 for x, that would be, oh wait, and dx dt, we have that, that's 6. So dx dt is 6. This is going to drop down, that's down. So I guess we could do this right now. So plugging in 6 right here, not 6, 6 goes right here. We're talking about at the point 4, so x equals 4. There and over here. So 4, 2 times 4 is 8, plus 1 is 9, so that's going to be 9. This, we said, was 6. Okay, over, this is 2. This is going to be the square root down here. 2 squared is 4, plus 4 plus 2 squared, now 4 squared, I keep saying 2, looking at that 2, 4 squared is 16, plus 4 is 20. Alright, so now we want to reduce that, that's going to be 3, and we want to reduce this, so that's going to be 27, that's going to be root 4 times root 5, that's 2 root 5, and that distance should still be in the same units as what we're talking about, so that should be centimeters per second. Okay? And again, don't plug that in too early. If you plug it in too early, it's going to mess up your derivative. Do the derivative, then you plug that in after. Alright, last one. I might get this in before. Probably not. The warning should be coming. I'll probably pause that. So I just said it, but alright. So these two problems, I know there's a couple of these on the assignment, this distance one. So you should just be able to look at this example and use it to do the ones in the book. Alright, the radius of a sphere is decreasing at, okay. So the radius is decreasing, so that's a rate, so dr dt. dr dt. All right, and it's decreasing at a rate of 2, so that's going to be -2 centimeters per second. At the instant when the radius is 3, that's going to be the post-derivative substitution. That's telling r equals 3, but that's after we take the derivative. What is the rate of change of the surface area? So that's pretty much telling you. I'm going to use A because it's, even though it's surface area, it's still an area. So that's dA dt, and put a question mark. Put that in your work. What is it that we're trying to find? I'm not going to draw a picture of a sphere, so that's pretty much it. So that's step 1 and 2. We don't need a picture of a sphere. That's not going to help us. So step 3 is the equation. So we need, we're talking about the surface area. So the formula for surface area, we talked about that on the other side, is 4 pi r squared. So that's step 3. There's no changes. Those are the only variables involved, r and a. So now we can take the derivative. So dA dt equals 8 pi r dr dt. All right, and so now we ought to be able to substitute a couple things in. So let's see, dA dt, and that's going to be 8 pi r is 3, and dr dt is -2. So that's going to be -48 pi, and area is going to be centimeters squared. All right, and one last thing. Explain the meaning of v prime of 3. So go ahead and pause the video and see if you can explain what that means. Okay, it's pretty basic, pretty simple. Okay, the derivative of velocity is acceleration, so it's the acceleration at t equals 3, and then whatever the units would be. That's it. That's what that means. Okay, so I'm going to get out of here before they set the alarm on me. You guys have a good weekend, or hopefully you've done this a couple days before, but anyway.